We're living in an era of dangerous dilettantes. A dilettante is someone who dabbles in a skill and is an amateur and who knows just enough to be very dangerous. For example, would you want a dilettante doctor who had done a little bit of research on pharmaceuticals and gives you some medicine? I mean, that's a witch doctor. Similarly, with software, we have lots of people claiming that AI is automating jobs and that agents solve all these problems. They are useful, but also automation has been around for decades. And if we go back to the Toyota Way, this is really where the beginning of DevOps started. The Toyota Way was formalized into a publication around 2001, right around the same time as the dot-com revolution, where lots of different startups were forming in the wake of the last crash. And if we look at some of the things that are part of the Toyota Way, they really are an antidote to every single thing you hear about people saying that software development is going to be automated, because Toyota itself has forms of automation and they've been doing this for decades. So if we think about some new automation technology, which is what narrow AI is, it's just an automation technology that puts together machine learning components and chains them together. This has been happening for decades in the automobile industry. And if we take a look at the Toyota Way, it really is a good way to flesh out the magical thinkers who are saying that AI is automating jobs. Because if you want to catch someone who is effectively a magical thinker, dilettante, ask them to explain the Toyota Way. And you'll find that they don't understand it. If you don't understand why these principles are so important, then you are a dilettante who is very dangerous and who is going to create software that eventually will implode and will cause problems in organizations. So let's go ahead and look at the 14 principles of the Toyota Way and actually analyze how they could play a role with these agents, which I do find useful. I think these agents are useful because if you give them a small task, they can complete them. But again, you have to think about this in the context of another industry like the automobile industry, which has a really high tolerance for looking at defects and making sure that they have to actually be exactly the way the car is specified. Otherwise, if you don't have this kind of methodology, you're going to kill people, right? Because you have wheels and engines, etc. So let's take a look at this 14 principles here. First, we have base your management decisions on a long-term philosophy, even at the expense of short-term financial goals. So what this tells us in terms of using agents or using these coding assistants is that the short-term gain you got from making a user interface with TypeScript, or the short-term gain you got from making a Python script, isn't the goal. The goal is to have long-term thinking, which is I want to build something that's going to work reliably in 1 year or 2 year or 3 years. And so this is a long-term philosophy, and that's very important when you hear about all this. I just got this done really quick. It's great if you can make things more effective or you can improve things, but the goal is long-term progress. Now let's take a look here next at create a continuous process flow to bring problems to the surface. This is so critical and so deep, and there's so much wisdom in this second step here. And this is really what we're at when we think about these agents is the goal of building something with an agent to hide the problems, which is a lot of what the dangerous dilettantes are saying, is like, oh, look at this, I built something, look, it looks like it might work, You're creating muda, which is waste. And by creating this waste, you're creating these hidden defects in the system. Instead of using an agent to have a continuous process flow to hide defects, with DevOps, your idea is that by pushing changes constantly into the system, you're flushing out problems. So the more you make changes, the more the problems are brought to the surface. So this is what's so critical about using agents, is that the default way you use them with these deceptive UIs is going to hide the defects. But if the agents are actually created in a way where they can surface the problems, this is going to be the critical way to use this technology. And so, for example, if you have very good linting and very good makefile and very good testing and end-to-end testing and formatting and compilation and performance testing and profiling, and that's what you're using this agent to do, then you're following the principle of the Toyota way. And this is the way to use an agent. Now let's take a look at this pull system to avoid overproduction. This is step 3. It says a pull system produces only the required material after a subsequent operation signals a need. So this is also pretty critical too, because many people are confused who are dilettantes that the more software you create, the better. In fact, it's the opposite. You want to use the least amount of software to solve a problem. And so where I would put this into the realm of an agent is, how can you ask an agent to do the least possible work? For example, I have a project that has really good test coverage and really good linting, and I want to add this one flag to a command line tool and one function. This would be a pull system approach. Now we also can think of step 4 here, which is level out the workload. So work like a tortoise, not the hare. This is also really critical, is that the idea here is that by doing things in spurts, like again, you're in a potentially really excited about generative AI tools and agents, and you start creating all the software, you don't want to do uneven production, because that's how the defects get hidden in the system. You want to have a very specific and consistent way of working so that the people, the equipment are actually predictable. Step 5 here is build a culture of stopping to fix problems to get the quality right the first time. Quality takes preference, and this is judoka. Any employee can stop the process to signal a quality issue. So this step 5 here is also really critical, and it's really the opposite of what we're hearing from these people who are saying AGI is right around the corner. Don't worry, put all these defects into production. No, in fact, it is not around the corner. The idea of AGI is more like the biblical rapture or aliens coming to Earth. It's a science fiction thing that is, there is no pathway from what we have currently to AGI. There's no evidence that it could possibly exist. If you're claiming these kinds of things, it's magical thinking. So instead of thinking about this future magical thing that will solve all your problems, let's solve the problem that we found right now. So if you have a failing test, fix the test. If you have a failing lint, fix the lint. Never let something that's failing or a quality control issue that you can see go into production. This is really the principle of DevOps, right? With CI/CD, is that you cannot push something into source control if it doesn't pass lint, if it doesn't pass test. And this is called, judoka, which is build a culture of stopping to fix a problem to get the quality right. Because the goal of software is to build things that are deterministic and that work, not to build software, right? That's a very important distinction. Now let's look at step 6 here, which is standardized tasks and processes for the foundation of continuous improvement and employee empowerment. So the idea here is that if you're using standardized processes like a makefile, even though makefiles have lots of, annoying, irritating things with them, for example, the syntax is not great and they're kind of, hard sometimes to work with. Well, makefiles are always available on Linux systems. Most software is deployed to a Linux system, and it makes it really easy if you always, across all kinds of languages and all kinds of projects, you do make format, you do make lint, you do make test, you do make deploy. Likewise, when it goes into the build system, it does the same thing. Make lint, make test, make format, make deploy, etc. So by building a standardized process, anytime you use any kind of a process, especially if you're using an advanced form of automation like an agent, you can actually have a very standardized way of working and reduce the defects. Let's look at step 7 here, which is use a visual control so no problems are hidden. And this is a part of the Toyota way as well. And this says that you want to make sure that you can see things. And so this is where I would look at reports like, for example, code coverage. Well, where do we have gaps in our testing? Right. And so that's where you could use an agent, is to improve your code coverage so that you can find gaps in your testing, and then look at the system and say, this is where we could use an agent this particular component has no tests. And so let's add a few tests here and then visually have a report. So then if there is a bug in production, we can look at that test coverage report and cross-reference it. Step 8 here is use only reliable, thoroughly tested technology that serves your people and processes. So in this case, what this means is that why use things that are theoretical? We should use things that are proven technology. So this is, again, why I would go to a makefile, or I would go to languages that have the strongest safety mechanisms. So, for example, Rust has very strong safety mechanisms and very strong reliability. Why not use the most tested, the most reliable systems versus the most easy systems? So I would say Python would be an anti-pattern, or JavaScript would be an anti-pattern, but TypeScript could be a pattern that is successful because we know TypeScript is much more reliable because it has strong typing, it's built into it. Or in the case of TypeScript, there's the Dino runtime, which is an even more strict version of TypeScript. So you want the more strict versions of technologies so you can serve things more effectively. And then step 9 is grow leaders who thoroughly understand the work, live the philosophy. So what this means is you don't want magical thinkers who say, hey, just put it into production, put it into production. The goal is to have people who understand this critical thinking aspect in the DevOps aspects of software engineering. Step 10 is develop exceptional people who follow your philosophy. Again, you should be training people. Step 11, respect your extended network of partners and challenge them to help you improve, right? So make sure you're partnering with the right people. And then step 12 is go and see yourself and understand the situations. This Genbutsu or Toyota managers are expected to experience the operations firsthand. This is really critical too with software engineering. It's really easy to just start, firing away. Just go, okay, come on, agent, fix it, agent, fix it. Wait, hold on for a second. Let's go to the root of the problem. Let's look at the failing test myself. What's failing? Let's look at the compilation error. What is actually happening? Let's look at the log messages and see exactly what's occurring. Let's run the application locally to make sure that we understand what's happening. A lot of times with automation, it's easy to keep running the automation, but instead you need to go to the subcomponent, look at the subcomponent and figure out why is that subcomponent working or not working. So this look and see is a very critical component that's often missed as well with these generative AI coding assistants. Step 13 here is make decisions slowly by consensus, considering all options here, right? So you should use critical thinking. And then step 4 is become a learning organization that practices relentless reflection and continuous improvement, or Kaizen. So this is really at the goal. Really, if we wrap up all of this, is that Kaizen, continuous improvement, is the point of software engineering. It's a living system, software. And so if you use these more advanced automation technologies like the narrow AI solutions, which are agents, the goal is to continuously improve the system, not to continuously destabilize the system. And so if you truly understand the Toyota way, when you talk about building things with agents, you will specifically mention these kinds of things that I just talked about. And so I think this is a really good way to find a magical thinker in your organization, or to find someone who's saying things that are just not true, or a dilettante who really doesn't understand how to build software in a production system, is that ask them about the Toyota way and have them explain to you how the things that they're doing follow these approaches, because in the real world, these approaches are not optional. In fact, they've been flushed out over decades in the Toyota automobile industry, and also even decades before that from the culture of the Japanese themselves. And so there's a lot of wisdom that's embedded inside of the Toyota way. And in the era of narrow AI, you need that wisdom. In fact, it's even more important to practice DevOps with these advanced automation technologies. So thought I would share some ideas here on how to really address the dangerous dilettante in the era of narrow AI.